Okay, so geoscience. It feels like it's really in the middle of something big right now.
Yeah, absolutely. It's more than just, finding new things. It's really about how the science gets done.
Right, how we learn, how we work together. Technology's a piece of it, sure.
A big piece, but maybe even bigger, is this massive push to make everything, well, open, data,
Yeah,
software, learning stuff.
totally. And it's like, if you want to get involved or just understand what's happening,
Hmm.
you kind of need a map, right?
Exactly. You need to know where these resources are, which brings us nicely to what we're digging into today.
Yeah, this specific webpage,
Yeah.
the Open Geosciences page on Alqubalee Notes, the version updated May 28th, 2025.
And it's presented not just as like a list, it's more of a guide, a curated map into this open geoscience world.
So our goal here isn't just to read off the links.
No, definitely not. We want to unpack it. What's the bigger picture it shows? What are the key tools and ideas it points to?
And what does all that mean for you listening, whether you're a student, researcher, educator?
Hmm. The page itself says it's a vital resource, right? Showcasing open source tools, education, collaboration.
Yeah, it really pushes that idea that this stuff is for everyone, beginners to pros.
So let's start where the page starts. It lays out this core idea. Geoscience is changing, fundamental.
Transforming, yeah. And it points straight at the drivers.
Open source tools, accessible education, people working together, collaborative initiatives.
Okay, so it's not just here's some stuff. It's advocating for something, isn't it? Open access, sharing knowledge.
Hmm.
Those principles seem central.
Precisely. The why is huge. It connects directly to empowering people, researchers, educators, students, the whole community.
To kind of build a more vibrant community, is that the idea?
Yeah, one based on innovation, collaboration, getting away from, knowledge locked up in silos or behind paywalls.
Towards something more open, more collective. Makes sense.
It really does. And if you're empowering people, skills are key, especially with these modern workflows.
Which leads right into the learning resources the page highlights, starting with open books.
Yes. And just look at the titles they list. It tells a story.
Right.
We see geospatial data science with Julia, or geocomputation with Python, geocomputation with R.
Ah, okay. So heavy on the coding, the computational side, reproducible analysis.
Exactly. That's fundamental now. And
Ah.
these books are the pathway in.
And I saw some really practical ones too, like applied geostatistics in Python, applied machine learning in Python,
Right. Often set up as online ebooks for courses. Very hands-on.
and even specific software guides like QGIS and mineral exploration. So applying open tools in industry,
Hmm. And beyond books, there are full courses listed.
like GeoPython or
Mhm.
automating GIS processes.
Yeah, using Python specifically for geodata tasks. And then there's machine learning in the geosciences.
Introducing ML, but focused on earth science problems.
Right. So it covers the basics, but also these advanced techniques. And crucially, they're openly accessible. You don't need like expensive university logins for these specific resources.
Okay, so you build the skills with these books and courses.
Sure.
Then you need the actual tools to do the science.
And the list of open source software on this page is, well, it's vast. It really shows the breadth of what's out there now.
Staggering, yeah. Covers pretty much everything, doesn't it?
Just about every subdiscipline, every step from getting the data to visualizing it, processing, analysis, modeling.
Maybe we could pick out a few examples,
Hmm.
just to give a flavor of the range.
Good idea. Like, take seismic and seismology. Big field.
Okay, what's available there?
Well, there's OpsBy. That's not just a single tool. It's a whole framework for processing seismic data. Really powerful.
Mhm.
Or Segio, specifically for handling SEG files, that standard seismic format. It's listed as fast, which is huge when you're dealing with massive seismic volumes.
Anyone who's worked with OGG knows that pain.
And Madagascar is even there, described as a full data processing suite.
Wow. Okay, what about something maybe a bit more specialized, like ground-penetrating radar, GPR?
Yep, cover two. You've got GPR Max for simulation. Simulating the physics is key to understanding GPR signals.
Right.
And GPR Pay for the processing and visualization side. It even mentions a GUI, a graphical interface.
Which makes it way more accessible if you're not, say, a Python guru.
Exactly. Lowers the barrier. How about well logs? Foundational data in oil and gas, groundwater.
That's listed there.
Things like LASIO, just for reading and writing the standard LAS files. Simple, but essential.
The workhorse format?
And WELI, which goes further into analyzing and processing the log data itself. Again, avoiding costly commercial packages for basic access and manipulation.
Okay. shifting focus. Simulation and modeling, that's huge across the board. Hydrogeology, geophysics.
You see ModFlow, the USGS groundwater model. Having the code for a standard like that open, that's big for transparency, for extending it.
Absolutely.
Then GenPy for 3D geological modeling, visualizing complex structures.
Yeah.
And SimPeg for simulation and inversion problems in geophysics.
Yeah. Open tools let researchers really get under the hood of the models.
Precisely. Adapt them, build on them. Then there's geostatistics, spatial analysis.
What's the open toolkit look like there?
Well, GeoStatsPy is mentioned basically bringing GSLib, a classic library, into Python, modernizing trusted methods, and scikit-gstat, which follows the style of SciPy, making it feel integrated with the wider scientific Python world.
Nice. And just general geospatial work, mapping, gridding.
Tools like Verde for processing spatial data, putting it onto grids, very common task.
Yep.
And Gmap sounds interesting using Google Earth Engine, but from Python within something like a Jupyter notebook.
Okay.
Makes that cloud power more accessible.
Right. Even fields like geochemistry have tools listed.
Yeah, FreeQC for simulating water rock reactions, complex stuff.
Okay.
And Pyrolite for handling and visualizing geochemical data.
And finally, showing your results. Visualization.
Essential. Tools like PyVista for 3D plots or IP Leaflet for making interactive 2D maps right in your notebook. Key for communication.
So wow. It's not just a scattergun approach. It's like an entire connected workbench covering workflows across different fields.
It really is. The sheer availability of these high-quality free tools, it changes the game.
And the page goes beyond just individual tools, right? It talks about platforms.
Yeah, environments that bring tools together or offer more complete workflows.
Yeah.
Super important for bigger projects.
Obvious ones are QGIS and GrassGIS, the big open source GIS platforms.
Absolutely. Integrated environments for spatial data, but also things like OpenTect, which is focused on seismic interpretation.
A different kind of integrated package.
And PanGeo. That one's highlighted as a community platform for big data geoscience.
So tackling those data sets that just won't fit on your laptop.
Exactly. Using cloud computing, parallel processing.
Yeah.
All within an open framework built on Python. That's really looking forward.
Okay, you've got skills, tools, platforms.
Yeah.
But you need the raw material, data.
The fuel, yeah. And the data repositories section on this page is just gold. Access to data is so often the bottleneck.
What kind of things are listed?
A real mix. The Digital Rocks portal images of rock microstructures, crucial for understanding porosity, flow.
Niche, but vital.
Geoscience Australia portal map data for a whole continent. SEG Open Data Catalog for Geophysics. Terra Nubis.
That's the open seismic repository, right? With
Yeah.
classic data sets like F3.
Yeah, F3, Penobscot. Standard data sets people use for research, for teaching. Having them freely available is massive.
Absolutely. Benchmark data.
And things like the Volve Data Village, a complete data set from an actual North Sea oil field. Imagine the analyses you could run on that.
Wow.
Global compilations, too, like the World Stress Map or MacroStrat for geologic map data.
The variety is just incredible. Different types, different scales.
It just smashes so many barriers. Studies that needed expensive data licenses or huge field campaigns. Maybe now you can start with open data.
It really democratizes things.
And finally, the page doesn't just dump links on you. It points to support and community.
Because having the tools isn't enough if you don't know how to use them or can't get help.
Exactly. So you find links to tutorials, cheat sheets, basic geoscience, geophysics, practical help.
And other learning bits like a virtual microscope, Alqubalee, interactive courses.
Yeah, things that add context, help you learn with the tools, practical application.
And community hubs.
Critically, yes. It lists the software underground Slack channel. That's where the people actually doing the stuff hang out.
Ask questions, share solutions, collaborate.
Right. It shows it's not just resources. It's a living community. People helping people use open geoscience tools and data.
Okay, so stepping back. This Alqubalee notes page, it's way more than just a list.
Oh, for sure. It's like a curated window onto this whole burgeoning ecosystem.
It really paints a picture of how open tools, open education, open data, they're all working together.
Making geoscience more accessible, definitely. More collaborative, faster innovation, maybe.
Seems likely. And for you listening, this isn't just abstract. This page is like a practical starting point.
Yeah, a direct route to getting your hands on real geoscience concepts, real data, using pro-level tools, often without spending a penny.
A way to jump into the modern way of doing things in this field.
What strikes me most, looking at everything this page points to, is just the sheer scale of what's freely available now.
Yeah, the breadth and depth are amazing.
So thinking about that, this huge ecosystem of software, data, learning materials, community support, all out there, what questions in geoscience, things that used to seem impossibly complex or just out of reach, what's possible now for anyone with enough curiosity to just dive in?
That's a powerful thought to end on. The landscape really has changed.